All right, let's talk about composition of functions. So composition is an operation of functions. Operation like add, subtract, multiply, and divide. Composition is what I call the nesting function, because what composition does is it takes one function, f, and it nests the other function, g. So first function is our outside function, second function is our inside function. Okay, so this is a nesting operation. So let's look at this with some examples. So let's say I have the function f of x equals 3x squared plus x minus 1. And I also have the function g of x equals, we'll say, square root of 3x plus 7. Okay? Now, if I want to compose these two functions together, let's say I want to do f composed with g of x. Okay? Well, that means my function f is my outside function. So f is my outside function, g is my inside function. So that means I'm taking g and plugging it into f. That is, everywhere here that I have an x, I'm going to replace that x with what g is equal to. Okay? A nice, easy way to do that is I'm going to rewrite I'm going to rewrite f. F is 3x squared plus x minus 1. I left big old blank spaces for x. Why? Because I don't want x there. I want g of x. Okay? But really, I don't want just the term g of x. I want what g of x stands for. G of x is the square root of 3x plus 7. Oops. So here is my composition. 3 times the square root of 3x plus 7 squared plus the square root of 3x plus 7 minus 1. Now, let's contrast that to what happens if we do this in the other order. We did f composed with g. What if we do g composed with f? Composition order matters because it changes which is the outside function and which is the inside function. Okay? So here, we're saying that g is the outside function, and into g, we're going to plug in f. So that means I start with g. G is the square root of 2 times x plus 7. But instead of x, I'm going to replace x with my function f of x. But f of x is equal to 3x squared plus x minus 1. So inside where that x was in g, I'm going to write 3x squared plus x minus 1. Notice that these two things, f composed with g and g composed with f, are not the same thing. That is to say, composition is not commutative. You can't switch the order. Order matters with composition. Okay? So that's the basics of composition. Now, what if we want to plug some numbers into a composition problem? Okay? So let's switch up our functions a little bit. So let's get 2 new functions and work with them some more. So let's look at f of x equals 3x plus 7. And let's look at g of x equals x squared minus 2x plus 1. Okay? So we could compose these functions. But what I want to do is think about what happens when we start sticking numbers in that composition. Okay? What happens if I want to do f composed with g of 1? Well, this means f is my outside function. So f is my outside function. Into f, I'm plugging in my function g. And into g, I'm not plugging in x, because this isn't an x. Into g, I'm plugging in the number 1. But do we know how to calculate g of 1? What does this mean in terms of function notation? This means I'm going to replace my x everywhere with 1. So g of 1 is 1 squared minus 2 times 1 plus 1. 1 squared is 1. 2 times 1 is 2. So 1 minus 2 is negative 1. Negative 1 plus 1 is 0. So g of 1 is 0. So that means I can think of f of g of 1, right? G of 1, though, is 0. So now I'm thinking of what is f of 0? F of 0 means everywhere up here that I had an x, I'm replacing that x with 0. 3 times 0 is 0 plus 7 is 7. So f composed with g of 1 is 7. Okay. Let's look at g composed with f of, let's do -2. Okay. So notice that I've switched the order, and order matters for composition. So now g is my outside function. So I have g with f plugged in, but instead of just plugging in x, I'm plugging in -2. All right, so let's unpack this. So in here, we're asking, what is f of -2? Well, we know how to calculate f of -2. That just means coming up to f and replacing all my x's with -2. 3 times -2 is -6. -6 plus 7 is 1. So f of -2 is the same thing as 1. So I can think of this as g of 1, because f of -2 and 1 are the same thing. Okay? So now, can we calculate g of 1? Hey, look, we already calculated g of 1. How handy is that? G of 1 is 1 squared minus 2 times 1 plus 1, which is 0. So g composed with f of -2 is 0. Okay? All right. Well, guess what? If we can compose functions, we can also decompose functions, which sounds a lot grosser than it is. Unfortunately, our functions are not going to be rotting. Okay, so let's think about this. Let's say I have some big function, h of x, that equals something like -3 over x plus 7 cubed minus 1. Okay? Now let's say I want to decompose h so that I can think of h as two functions. I want to find an f and a g such that h is f composed with g of x. Okay? Remember what this means. This says f is my outside function, g is my inside function. Okay? Well, one of the easiest ways to do this is to say, okay, I'm going to try and find an inside function. Now, here's the thing with composition. There's more than one correct answer. So is there something up here that I can think of as an inside function? Well, what if I let my g be equal to x plus 7? That's certainly inside the cubing function. Well, then I've used this up, and what's left to be my f? Well, then f is going to be equal to -3 over x cubed minus 1. Notice that if I plug x plus 1 in for x, I'd be back to -3 over x plus 7 cubed minus 1, right back where we started. So here's one way that you can decompose h into two functions. It's not the only way, okay? But it is one way. So composition and decomposition, thinking of nesting functions. Composition is a nesting activity, okay?